Hi class, welcome back. Today's program on Geom Revise, we are going to look at wave intensity, and this is class by Raj. Okay, now this diagram is actually a very important diagram. You can get a lot of information or concept from this diagram. Now what do you see is you see a source power, and then there is a spherical wavefront, okay, and then the surface area is 4 pi r squared. Then here we have area, okay, a small particular area here, and then the intensity at the surface of sphere is intensity is equals to power over area. Okay, so you realize that as the radius increases, okay, r to r, 3r, then you realize that the area is also increases. But when the area increases, we also realize that the intensity seems to be decreasing. Okay, so this is a very important information. So let's go on and learn more about wave intensity. Now, wave intensity, now the first thing is the definition. Okay, the symbol is a capital I. Okay, I can symbol wave intensity with a capital I. Okay, hold on, with a capital I, wave intensity. Now, the first thing is the definition. Is energy per second. Energy per second means E over T. Transferred by the wave to a unit surface area. Okay, that means over A. Perpendicular to the direction of wave propagation. Okay, so it must be perpendicular. Now, E over T is actually is power over area. So this is the definition for intensity, and this is the formula. Now, what will be the unit? The unit for power is watt, okay, which symbol is capital W, and the unit for area is meter square. So the unit for intensity will be watt per meter square. Okay. Now, the most important thing about wave intensity is the relation. Now, what is the relation? Intensity of the wave is directly proportional to the square of its amplitude. That means intensity is directly proportional to the square of its amplitude. Okay, to understand wave intensity, we can divide based on their source. We have a point source and we have a linear source. Okay, now example of a point source is something like this, is one point here. Okay, and you see that the wave emitting wave in all direction. Okay, it emits wave in all direction. Okay, all right. Now the wavefront is called as a spherical wavefront. Okay, now this is the spherical wavefront. Okay, spherical what? Spherical wavefront. Okay, now go back to this one. This is the basic formula for intensity. So power over area. So here for point source, spherical wavefront, so the area for sphere will be 4 pi r squared. So from this, you realize that the intensity is inversely proportional to r squared. Correct? So if I look this, um, this is intensity is uh, inversely proportional to r squared. Okay, all right, 4 point source, right? Now, so that's why this is very important. Okay, now then we know based on the relation that intensity is directly proportional to the square of its amplitude. Correct or not? Small a or big A lah. Okay, so then we realize that the amplitude square is inversely proportional to r squared. Okay, we substitute this inside here. Then this shows that the amplitude is inversely proportional to r. Okay, so this is very important that you have to know. Okay, now for a linear source, okay, this is an example for a linear source. Linear source will form a cylindrical wavefront or a circular wavefront. Now, why do they say the word is a circular wavefront? Is because of this top here. Okay, when you don't have depth. This is all circular wavefront. But when you have depth, then it will form a cylindrical wavefront. Okay. Now go back to the basic. This is the definition of intensity. Intensity is power over area. Then what is the area? What is the area for the cylinder? Is 2 pi RL. Okay. So that from here you know that the intensity is inversely proportional to R. Correct or not? This is R. So intensity is inversely proportional to R. So then this is very important. So from the relation, intensity is small a or big A lah, is directly proportional to square of its amplitude. Okay. So therefore I can say A square is this, inversely proportional to R square, then I get this. So this is very important. So can you see the difference? When the sources are getting different, then you realize that the three important, this relation of intensity with R is different, amplitude with R is different, and then here also you see is different, and here also you see is different. So it's very important in a question to detect first what is the source. Very, very important. Okay. All right. So let's move on to the next one. Okay. Knowing that concept, now let's try to apply in our past year's question. STPM 2018. Now, the intensity of a wave at a point 2 meter, that means the first point, okay, which the R1 is 2 meter, from the point source. So this means it is a point source, okay, is 8.8 times 10 to the power of negative 9. So the first intensity is 8.8 times 10 to the power negative 9. What is the intensity of wave at 3.5 meter from the point source? So they give you R2, they ask you to find I2. Now let's go back to what we have studied. The concept says for a point source, the intensity is inversely proportional to R square. So when you do ratio, you will get your answer something like this. Okay, so I1 is, you substitute the value, I2 is something we want to find, R2 is 3.5 and R1 is 2. Okay, so you solve this, you should get your answer for I2. Okay, tell me what's the answer for I2, class. Okay, use your calculator and get for me the answer for I2. Okay, all right. Now this is math, yeah. Okay, so let's move on to the next question. Okay, now before we move on to the next question, let's learn about the intensity of sound wave. Okay, all right. Okay, now let's move on. Now, for intensity of sound wave, there's a bit more extra quantity there. Okay, the quantity is called as intensity level of sound wave. Okay, there's a difference actually between the intensity of a sound intensity and intensity level. There's two differences there. Now, what is intensity level? It's the difference of loudness between the intensity of a sound and the standard intensity is called intensity level. Okay, so that means you are comparing. You see why we will need to compare is because the word loudness is very, very subjective. We cannot measure how loud a person is or how soft a person is. But we can differentiate the loudness by comparing the loudness between the intensity of a sound and the standard intensity. Okay, and this is called as intensity level. Okay, all right. So unit is normally expressed in the unit decibel, dB, and this is the formula for the level of intensity. Okay, so you see here in this diagram here we have a quiet library, which is like, you know, quiet library, and then here we have a threshold of hearing. Okay, so we can compare all these other intensity based on the standard intensity, which is the threshold of hearing. Okay, so that's why the formula is called as level of intensity equals to 10 log 10 I over I naught. I is what? Is the intensity of sound that we want to measure, and I naught is the standard intensity, which is the threshold of hearing. So like say for example, I would take an example here. Okay, I want to see the level of intensity. Okay, now let's take at example here, maybe a quiet library. The level of intensity is this much. So this is I1. Okay, I'm going to put I1. And then level of intensity will be what? Level of intensity, okay, is 10 log 10 I1 over standard intensity, which is always will be a threshold of hearing. Okay, so that's why it is 1 times 10 to the power of negative 12. Okay, all right. Okay, now this question came out in STPM 2017, essay question. The question asked was, distinguish between the intensity of sound. Okay, they ask us to distinguish what? Between the intensity of sound and the intensity level of sound. Okay, so these are the difference. All right, now what is intensity of sound? Now it goes back to the basic formula, which is I equals to power over area. So the intensity of a sound is the power of the sound in watt divided by the area of the sound covered in square meter. Okay. But intensity level of sound, it tells you the level of the sound relative to a reference intensity rather than the actual intensity. That means in the formula, the reference intensity will be the threshold of hearing. This I0 is actually a, a reference intensity. Okay. Now, intensity of sound is measured in watts per meter square. Okay. But level of sound is quoted in decibel. Okay. So this is the formula and this one is the formula here. So you can see the difference here is the comparison of the sound energy of a noise with that of one just detectable at the threshold of hearing. But intensity is absolute measurement of the sound energy incident on an area in a given time. So it's this. And intensity level is comparison. Okay, so that is the difference. Okay, let's look at this question which came out in STPM 2016. Now, the intensity level of a sound. Okay, be careful with this word. It says what? The intensity level of a sound. That means it's a comparison at a distance of 50 cm. That means R1 is 50 cm from a point source. Okay, see, it's a point source. Is 65 decibel. 65 decibel is the intensity level of sound. What is the power? They want us to know power or want us to find power produced by the source. So the threshold intensity of hearing is this much. That means this one is the reference intensity. So we want to see comparison. Okay. Now go back to the one that we studied, the formula. The level of intensity equals to 10 log 10 I over I0 decibel. Level of intensity is 65 decibel. Okay. Now what we must do is we can divide this into two parts. Okay. The first part is to find the intensity of I. We need to find the intensity of I first. So now we see here 65. Okay, let me hold this. 65, 10 log 10 I over threshold of hearing, which is the reference intensity. Okay, then you do your maths. Okay, what happened? I brought it here and then I solve this. So I get my I is 3.16 times 10 to the power of 6, negative 6. Okay, so I already got my I. So my step 2 is to use the definition formula for intensity, because what they want is they want the power, and the power, we know intensity is power over area. I already got my intensity from the step 1. Okay, I know my area, correct? Now I need to find my power. So step 2, intensity is this, power. Area is what? Because it says it is a point source. It says it's a point source. So area for will be 4 pi r square. So I put r. okay, which is R1 here. Okay, you can see here, and then I solve it, then I got my power in watt. Okay, let's check on this question here. STPM 2018, it came out in an essay question. A firecracker explodes in the air at a height of 10 meters. So like this, okay, it explodes vertically above a boy, okay. The intensity level, okay, be careful with the word intensity level, okay, that means it's actually referring to what? It's referring to I. Okay, hold on. Intensity level, okay, is actually referring to intensity level. Intensity level is what? Of the sound is what? Is 60 decibel. Okay. Now, they ask you to calculate the power of sound for the explosion of the firecracker. So, you see, this one is similar like the one we did just now, right? What was the two step? First thing was to find the intensity. Second is to find the power. So, similar way of doing it. Okay, so go back to the basic formula, which is the intensity level of sound, 60 equals to 10 log 10 I over reference intensity, which is the threshold of hearing. Okay, solve this and then you get the intensity is 1 times 10 to the power of negative 6 watt per meter square. Okay, all right, then you want to find power, you go back to the definition formula, put your intensity value here. Okay, then your R, because why? It's a point source. Okay, so then you find your power, so you got your answer. So fast, you know your way of doing it, you already got like 4 marks. Okay, now the next question B, it says determine the intensity level of the explosion heard by another boy which is 15 meters from the explosion site. I will explain this to you later, but I want to go to C first, which is differentiate between the propagation of sound and light. Okay, what do they mean by the word propagation? Now, wave propagation means is any of the way in which wave travels. So that means how or in which the wave travels. Okay. Now, we're going to talk about how the sound wave travels and we're going to talk about how the light wave travel. They ask us to differentiate between the sound wave travel and the light wave travel. Okay. Now, first thing, the propagation of sound. We know sound is a mechanical wave, okay, and light is an electromagnetical wave. That is the first difference. Okay, now mechanical wave means it needs a medium, correct, and we know based on our prior knowledge electromagnetic wave can propagate in vacuum and medium. See, there's another difference. Okay, now why sound needs medium? Because sound use the help of the vibration of the particle in order to propagate, that means to move forward. So it need to propagate with the vibration of particle. But electromagnetical wave, which is the light wave, one of the examples is the light wave, it can travel in a vacuum because it travels by the oscillation of electric field and magnetic field. See? Alright? But here they ask you is 2 marks. So you only have to state 2 points. Either this point, or you can also state this point. Okay? So you will get your full mark. Okay. Now let's look at this part here B. Determine the intensity level. Okay, so they want us to determine what intensity level. That means it refer to the 10 log 10 I1 over I0, kan? Explosion heard by another boy. So the another boy is this guy here. Okay, 15 meter from the explosion site. So this is the way how I visualize. Okay, it's a very simple way of to visualize it. Okay, so this is the source, which is boom. Okay, explosion site, and then we know this is a point source and it emits wave in all direction. Okay, macam ni. Alright, so the level of intensity, because we know I is inversely proportional to r square. So that means it's the same lah for every point kan. So we find the beta 1. Okay, I'm going to symbolize the level of intensity for the first boy is beta 1 at this particular point because it's the same here. Okay, even though it's here, but it's the same here because the radius is still the same. So tan log 10 I1 over I0. Okay, then this guy here, he sits at the radius of 15 meter. So I find the level of intensity in comparison to the standard intensity, which is I0. So I get beta 2. Okay, 10 log 10 I2 over I0. But they ask us to determine the intensity level of the explosion heard by another boy, which is 15 meter. So we must take beta 2 minus with beta 1. Beta 2 here minus with beta 1. Okay. Now, in comparison of what this guy here heard to what this guy here. Okay. So now, the first formula, okay, beta 2 minus with the second formula, which is beta 1. Okay. Then what did I do? I factorize. And then we know if I2 over I0 means it's minus. Okay, so minus. So minus log I1 minus becomes plus. Minus becomes plus. And then this one can delete. Okay, so then you get back like this. Okay, then beta 1 is 60 from the previous slide. And then you solve this. Okay, you can solve this by finding I2. Okay, and then you can get your answer. Or what you can do is, since you know the radius, one is 15 meter and one is 10, one is 15 and one is 10, you can also substitute in this manner because it's a point source, and then you can find the value of your beta 2. Okay, so what I'm going to give you homework now, I want you to find the value of beta 2 and let me know. Alright, okay, so that is how you solve the question.